Hello, everybody. So let's finish up the rest of this Regents. Let's start with number 15. So when you read number 15, the equation that represents the sequence is, you may look at the answer choices and say, all right, that reminds me of something, right? It's a sequence. Go to your reference table. What are we doing to get from -2 to -5 and then -5 to -8? We are subtracting 3. Okay. Now I know I'm going a little bit quickly. Um, if you want to stop before like I make my statements, stop it, get your answer, then compare it to mine. Okay. So your common difference is -3. Therefore, I know it's an arithmetic sequence, which is on the formula sheet for the regions. A1 plus n minus 1 times D. My A1 stands for my initial term, which is -2. My D is -3. I think on the reference table, they put the D before the N minus 1. And so choice 1 and 3 are out because of this, the -2 starting. And then the common difference is -3. So that is choice 2. Okay. So number 16 gives you a dot plot. It asks you to compare the mean, median, mode. Right away, you could see the mode is 3 because the most number of data points lie there. So your mode is 3. Okay. Again, to find the median, you may want to cross out, like start crossing out, find the middle. Or you could say how many data points, count them up 1, 2, 3, 4, 5, 6. It comes out to be 20. So there's 20 data points, right? The middle of your 20 is between 10 and 11, right? So you could, again, you cross out. You could say, okay, I'm going to cross out here, right? That's that point. I'm going to cross out here. Then I'll cross out here. Then I'll cross out here until you get to that middle. You could also write it out as 0, 0, 0, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 3, 3, etc. You could also do it in your calculator, which I will do in a second. Um, and then the mean is 0 3 times, 1 3 times, 2 4 times, 3 5 times. So again, you could tally that up on your calculator by hand, or again, if you wanted to just go to your calculator, right? I just want to review this with you. Oops. All right, 1 second. Let me just make sure it's sharing my calculator and not my document. So hold on 1 second. Oh, here it is. Here's the calculator. All right, so you should be seeing my calculator at this point, right? And you could just go into stat, okay, and edit. Okay, so I've already put all the data in there, all my zeros, my ones, my twos, my threes, my fours, my fives, my sixes. You could also use L1 and L2 if you want to, um, and do it as two variable statistics, like a frequency. My doggy. Um, okay, but then at that point, you press stat and you go over to calc and you do one variable stats, enter, 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 and you get your mean X bar, which is 2.5, your median MED, which if you scroll down is also 2.5. And you know your mode from before, which was 3. So when we go back to the original document, which is right here, we see that the mean and the median are the same, choice 2. Okay. So number 17, the students in Mrs. Smith's algebra class were asked to describe the graph of g of x compared to f of x. Which student response is correct? Okay, so what you can just do is put them right into your calculator. Let me share my calculator again. Okay, I entered already into y1, the g of x graph, and into y2, the f of x graph. Again, you could reverse them, just be sure which one is which. You also may remember some of the transformation rules here, which would be great as well. Okay, anyway, when I go to graph them, I see that my g of x graph, that was my y1. Okay, so let's just see if it'll graph it from scratch. It's already graphed it, so it's fine. My g of x is this one. My f of x is this one, because it was my second one. Okay, so when you graph it, you should see the same thing. So my g of x graph has been moved 3 to the right. It's also more narrow than the original, the f of x. So let's see who's right. And again, you should be doing this on your own, trying this on your own, not just watching me do it, because that's how you get good at it. So let's just take a look. It's shifted 3 right. It's narrower, the g of x graph, and that is choice 4. Okay. Number 18, one Saturday, Dave took a long bike ride. The graph below models his trip. What was Dave's average rate of change? When you hear average rate of change, it is slope on this trip. So they want from the beginning to the end here. The end we see we're at the point 5.5, comma 55. So we just use the slope formula, y2 minus y1 over x2 minus x1. Our original point is 0, 0, right? So x1, y1, x2, y2. So 55 minus 0 over 5.5 minus 0. And if you do the division, whether or not you do it in your calculator or not, you do 55 divided by 5.5 and you get 10. So just remember your biggest takeaway is average rate of change, which is slope. All right. Let me just make sure that I'm on, hello, on this document. Sometimes it just doesn't let me know, or maybe I just don't know whether I'm on the calculator or the document. All right. Number 19. So which expression is equivalent to this one? Again, if you were really in a pickle and you didn't want to do the algebra, you could plug in numbers, right? You could plug in like x is 1, right? Figure out what this comes out to, and then plug in 1 into each of the answer choices and see which one matches. I'm going to actually do the math just because, again, if you got this on a part 2, most likely you would need to do it by hand. I mean, not, it would be on a part 2 most likely, but you would have to do this by hand if you needed credit on that part 2. Okay, so here we go. So we're going to double distribute. So x times 2x, x times 2x, x times 7, negative 5 times 2x, and negative 5 times 7. So we get 2x squared, we get 7x, we get negative 10x, we get negative 35. This comes out to be negative 3x. So we get 2x squared minus 3x minus 35. Remember to switch signs when you're distributing that negative. So you get negative x minus 5. So 2x squared minus 4x. So take this out and this out. And then negative 35 minus 5 is negative 40. Okay. 20, here we go. The functions f of x and g of x are graphed on the set of axes below. What is the solution to this equation? Okay, it's saying what are the x values when the y's are equal? So they intersect here and here. Those are solutions. this point is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5, 5. And this point is 1, -3. So when the y's are equal, what are the x values? The x values are 1 and 5, which is choice 1. Okay, great job. 21. When babysitting, Nicole charges an hourly rate and an additional charge for gas. This question comes up all the time. Linear function, right? That flat fee. And the additional per, right, with the slope. So she uses the function, excuse me, C of H equals 6H plus 5 to determine how much to charge for babysitting. The constant term of this function represents. Remember, the constant term does not have the variable there. So what would that represent? The flat amount. So she charges an hourly rate of that $5. And then she would charge an additional $6 additional charge for gas, right? Oh, sorry. Yeah. Nope. Let me go back. Erase everything I just said. She charges an hourly rate, right? Rate is slope, and an additional charge for gas. Okay, so one flat fee for gas. Her flat fee for gas would be $5, right? So flat fee for gas. Because it wouldn't make sense that she would just charge $5 for babysitting and then $6. She's not driving around. She's not driving the kid around, right? So you also have to make common sense of that. So flat fee of $5 for gas. And then she's charging an hourly rate. Rate is slope. So the M is 6. And that's her fee. So $6 per hour. So the constant term, which is 5, represents that flat fee for gas. So it is not her hourly rate. It's not the number of hours because that's H. The total would be C of H. So it would be the additional charge for gas. So this would be C of H. The number of hours would be H. The hourly rate would be 6. And then the additional charge for gas is 5. Okay, great job. All right, 22. When solve for x in terms of a, this means you're doing x equals, and in your answer, you will have a. It wants the solution to this equation. So that means I need to get x's on one side and my everything else on the other. So what am I going to do? I'm going to subtract ax to this side. I'm going to add 7 to the other side. So right now, I have 3x minus ax equals 12. Again, look here, they both have an x. You're going backwards. So you're factoring. Take out the x, and you're left with 3 minus a, right? Reverse distributing equals 12. I took out the greatest common factor, however you want to call it. And then I divide by 3 minus a. I divide by 3 minus a. So x is equal to 12 over 3 minus a. Great job. Okay, 23. 23 is a fun question because, again, eventually, or you may have learned how to actually do it from scratch, right, in class. But what you really can do here, right, in case you forgot or like it always confuses you, it says here it wants his speed in miles per hour. So that means we have to have miles on the top, hours on the bottom. So I say to myself, okay, I could play the cross out game. Like here, I could cross out when I look on number 1. Can I cross out going up and down anywhere? No. That's not a choice. Now you may be saying, I don't know what she means about crossing out. You'll see in a second. Because remember, anything over itself is 1. So, like, for instance, on choice 2, m divided by m, that crosses out. Seconds are on the both on the bottom, and miles and hours are in the top. So I'm not left with m over my hours. That's out. On choice 3, my m's cross out, my seconds cross out. Oh, I'm left with miles over hours. So it's choice 3. It looks like I always check my next one, right? I don't have miles in top and bottom. They're both in the top. So my M. So I know it's not choice 4. So that's kind of like the cross out game. Um, in case again, for some students, it's hard to like know, okay, what goes on top, what goes on bottom. But if you do it this way, it kind of like will facilitate that process. All right. And then 24, which function has a domain of all real numbers and a range greater than or equal to 3? All right, number 1 is a line. So a line does have a domain of all real numbers, meaning you could put in anything. But when you put in anything, the range is all real numbers as well. So you take that out. Again, you can put this in your calculator if you need to. Number 2 is a parabola. I know that because it's a quadratic. It's a parabola that whose y-intercept is 3. So the domain would be all real numbers because I'd be putting in anything, but I'd only get values in the range that are greater than or equal to 3 because I start at 3. So this would be the answer. Okay, I think I've frozen, so I'm gonna just stop my video for a second. All right. And again, you could just plug this into your calculator. Choice 3 is an exponential function, which looks like this when you plug it into your calculator. The domain is all reals, but the range is reals greater than or equal to 0. Domain are x's and range are y's. Okay, so that's not it. And 4 is your absolute value. When you put into your calculator, don't forget when you put that into your calculator, you have to press math, go over to number, and then it's number 1 ABS. You'll see that it's absolute value graph, move 3 places to the left. So that's not it, because that would be a domain of all reals, but the range would be greater than or equal to 0. So it would be choice 2. Okay, great listening. I know that that was a little quick. You may want to put 24 into your calculator if you're not familiar with some of those functions, but good job listening. Again, go back to anything that may have given you difficulty. Remembering we started here at question number 15. Have a great day.